In section 2, we took a look at solving systems of equations using substitution and elimination. So what I did here is I put the steps for substitution and elimination down just to review. So for solving a system of equations by substitution, step 1 is to solve one equation for one of the variables. Now sometimes step 1 may already be done for you. If you already have an equation that's x equals or y equals, step 1 would already be done. So you may have to start at step 2, where you substitute that expression for the variable found in step 1 into the other equation. So if you have x equals, you take what it's equal and substitute it into the first equation for x. In step 3, we're now going to solve the new equation for the first variable. And once we find that variable, we go to step 4, where we find the value of the other variable by plugging in the solution found in step 3 into one of the original equations. So substitution, I feel like, has a lot of steps to it. Even though there's only 4 written here, I feel like there's more work to be done in some cases for substitution. So I prefer elimination. So in order to solve a system of equations by elimination, we want to rewrite or make sure both equations are in standard form. ax plus by equals c. Now, I won't use elimination if they're not already both in standard form, because otherwise substitution is already set up for me. It's more work to do elimination in that case. So what the biggest part of elimination is step 2. Multiplying one or both equations by a non-zero number, so the coefficient of one variable in one equation is the opposite of the coefficient in the second equation. And step 2 is kind of difficult to understand by words. It's easier to see in an example. So basically the number in front of x or the number in front of y has to be the same in both equations, but one of them is positive and one of them is negative. Step 3 is huge. We're adding the equations together after they have the same coefficient but opposite signs. So we add them together. That allows you to find the value of the first variable, because one of the variables will eliminate when we do step 3. And then lastly, in step 5, we plug the value into one of the original equations to solve for the second variable. I find it's actually easier to follow the steps for substitution and elimination by doing an example, not so much as just reading the steps to understand the process. So I'm going to do an example of each. So our first equation, x plus y equals 12 and y equals x plus 2. Sometimes they'll already be set up for a case. And in this case, it's already set up for substitution. I already have a variable that's isolated. I have this equation that's y equals x plus 2. So what we're going to go and do is we're going to take this x plus 2 and plug it in for y in our first equation. So that's going to give us x plus 2 equals 12. Now I have an equation that's only x, which I can use to solve for x. So when I combine like terms, I get 2x plus 2 equals 12. We're going to subtract 2 from both sides, so we get 2x equals 10. Divide both sides by 2, and we get x equals 5. Now I want to plug x equals 5 into one of my original equations. The nice thing is I have that second equation that's y equals x plus 2. Don't try to overcomplicate it by plugging into a more difficult equation. So it's easier to plug it in for the y equals x plus 2. So y equals 5 plus 2, and 5 plus 2 is 7. So you have two options when you have your final answer. You can leave it as x equals 5, y equals 7, or you can write your solution as a point. Whenever we write a solution as a point, we separate it as x comma y, and we always put parentheses around a point. A very common mistake I see with parentheses, with writing points, is not putting the parentheses. We gotta have those parentheses. So that's an example of substitution. I typically will use substitution when a variable is already solved for, or in a case where it's that first equation where it's just x plus y equals something. I could use substitution in that case because it'd be easy to get x or y isolated. Okay. So our second example, we have x minus y equals -6 and x plus 2y equals 15. So this is an example where I'm going to use elimination. Okay. And I could actually eliminate either x or y here. I have a choice. So sometimes one variable is going to be easier to eliminate than the other. So there's a couple things I look for when trying to decide which variable to eliminate. The first is, can I multiply only one equation? I try not to multiply both equations if I don't have to. Secondly, I look to see, does one variable already have opposite signs? So those are the two things I look for. If I can only multiply one equation, and if one variable already has opposite signs. So if I look, I have a -y and a plus 2y. So the y's already have opposite signs. So that's a big thing for me, because I don't want to have to multiply by a negative. A lot of mistakes can happen when multiplying by a negative. So next I see, okay, can I make the coefficients of y the same by multiplying only one equation? And the answer is yes. I can easily take this first equation and multiply everything by 2 and have the coefficients the same. Now the second choice here, because my x's are both x, I could have easily multiplied one of the equations to get them to have opposite signs because they already had the same coefficient. But again, I like to avoid multiplying by a negative just in case I make a mistake. I'll show you that second case here in a little bit so you can see you get the same answer no matter what. So when I go through and multiply every term in the first equation by 2, we get 2x minus 2y equals -12. Gotta remember to multiply everything by 2. That's a key thing. My second equation is not changing, so x plus 2y equals 15. So now becomes step 3, where we add these equations together. When we add these equations together, 2x plus x becomes 3x. The y's cancel, they eliminate. A -2y and a positive 2y becomes 0, so I don't have to write it. And then -12 plus 15 becomes 3. So I'm now just left with 3x equals 3. Divide both sides by 3, and we get x equals 1. So now I want to go ahead and plug this into one of my original 2 equations in order to solve for y. So again, I get very particular when I'm deciding which equation to plug into. So I like to avoid equations with negatives because again, mistakes can happen. So I'm going to plug it into the second equation. X plus 2y, so 1 plus 2y equals 15. This way I'm avoiding the negative with the y in the first equation and the -6. So first step to solve for y is going to be to subtract 1 from both sides. We're going to get 2y equals 14. Then we're going to divide both sides by 2. And we're going to get y equals 7. So again, you have 2 choices. You can leave it as x equals 1, y equals 7. Or you can write your solution as a point. So again, when I write my solution as a point, I'm going to have x comma y, so 1 comma 7 with the parentheses. Okay. Now I'm going to solve the equation again, but this time I'm going to eliminate x first, just so I can show you what would have happened if we had eliminated x first. So in this case, the x's are already the same coefficient. They're both 1s. Now I just need one of them be a negative. So I have choices. I can either multiply the first equation by the negative, or I can multiply the second equation by the negative. I'm going to go ahead and multiply the first equation by the negative. It doesn't matter which one. So this time I multiply every term by -1, and we get negative x plus y equals 6. This is why I try to avoid multiplying by negatives. You have to remember to change the sign of everything. My second equation is to stay the same, x plus 2y equals 15. And we're still going to add the equations together. This time when we add the equations together, the x's cancel because negative x plus x is 0. Y plus 2y is going to be 3y, and 6 plus 15 is going to be 21. So in order to solve for y, we're going to divide both sides by 3, and we get y equals 7. So again, now we got y equals 7 again, which is great. Now we want to plug it into one of the original equations to solve for x. Again, I'm going to avoid negatives. I'm going to plug it into that second equation. So x plus 2y, so 2 times 7 equals 15. So we get x plus 14 equals 15. And then subtracting 14 from both sides, we get x equals 1. So again, we got the exact same solution, y equals 7, x equals 1, which we still write as the point 1, 7. It doesn't matter that we solve for y first, it's always x, y. So hopefully this clears up any questions you still had over substitution and elimination. Most of the time you guys are going to have a choice as to which method you want to use to solve a system of equations. So if you prefer one method over the other, you can always use that. I am going to ask you to specifically use some methods though. I want to make sure you know how to do both, even if one of them you prefer. Like I prefer elimination, but I can still use substitution to solve a system of equations if I need to. Please let me know if you have any questions.